Sorry for reacting like that, Jesse, and giving it away. All right, live streaming. Now I have to start over. I've had to do this every single day. Um, I got some feedback from more than one person with given the sense that like there's a whole lot of material to learn. That each thing in isolation is, easy enough to follow and to understand what it does. But how are we supposed to then start synthesizing that and start actually like knowing where do you start from scratch when you write a big program? And like uh, I just told everyone before starting the stream because I forgot that like that is not at all the expectation right now. We are using the activities and the projects and stuff as a way to just sort of get comfortable with using the principles, and they're cool and they're cohesive and everything because I already know how to do this, and like that should not be where anybody is yet. Especially with JavaScript, we just started getting into it. It's sort of like it's like learning how to. It's a craft. It's like learning how to build houses or build anything. You're we are right now at the area in your learning where, for most of you probably, we have a box of tools and you're starting to learn how to like build stuff. And we're still going through the box and saying this is a hammer, this is a screwdriver, this is what they do. And we're like building, little example things as a way to as a means to exercise them. But there's no way that you're going to be knowing how to build a large thing with this stuff until you do it a lot. It's a craft. It's something where there's no way around this. Um, the only way to get a sense of what these tools are for and how to use them is to just do it enough until you get to that point. So just stick with it, and that's all. That said, there's more tools. We're going to learn more things today. Really don't worry if it's overwhelming right now, if you're getting lost. There's plenty more time. A lot of the things we've talked about are like things I've added in that don't actually have to be uh, learned right now, and I've sort of glossed over some details in them. And people are going to be going in much greater depth and back over some of the same things in the following weeks. So there's quite a bit. There's 3 more weeks of just introductory JavaScript, and then you'll really maybe start doing stuff with it. So there's quite a lot of material here, but we're getting at least through the stuff which is like this is a brand new concept, this is another brand new concept, and just don't worry if you can't keep them all together right away. Okay, so today pretty much everything is about just more stuff about functions. Functions are, like I said, they're sort of everywhere. They're used for all kinds of different purposes, and they are very tricky in a lot of ways because a function does things. It's not just a static value. It's an actual process. It's an actual thing that the computer is doing. And to say that now, okay, you take this process and you move it over here, you pass it to another process or whatever, it starts to get very confusing. It's very hard to think about for normal people because it's not really, it's not a tangible idea in the way that a book would be, or a number, or something that's much more directly simple. So we're gonna just keep going through more things that functions can do. Again, this is gonna take a while to get the hang of it. This is the big, very difficult tool. This is like the lathe or the whatever a very large and difficult tool to learn how to use is. That's the function. Okay, so we're going to start with a review. And we started, we showed this yesterday. There's 3 ways that you can create functions. This is sort of for historical reasons, but also one of them is very important. This middle one, you can assign a function to a value. That's, a very, very important thing to be able to do, because that means you can then assign a function to a variable. It means you can take that variable and then hand it off somewhere else, pass it to a function, return it from a function, and all of the things that any other value can do, a function can do, because a function is just one value. And it's, in fact, We'll get to this later, but it's a first-class value, which exactly means that thing. It's something that any other value can do. You can do with a function. So you can declare it here. If you just leave off the equals, you're not assigning it to anyone. You're just saying there, declare this function with this name. This works just as well. Assignment is when you make here an expression, which is an anonymous function, and then you bind that to a variable. So same result, you have a function with this name, but you did it in a different way. And then this third one is an arrow function. You've seen these short ones with the arrow. And this is also an assignment because we're taking an arrow function on the right here. We're assigning it to a variable. Same result. Arrow functions are slightly different with how they deal with scope, but we won't get into that right now. So that's it, though. There's 3 ways. All of them lead to a function. They all will do the same thing because, see, we're returning x plus 1. This one's a shorthand for returning. And you would be able to call all 3 of them and get the same result. Okay, the other thing we looked at is anonymous functions. So if you just took the right half of the previous stuff, so if you just look at this part here, this is what we're assigning. This is an expression. So this is not, it's not bound to any variable until we assign it here with this assignment. If we don't do that, if we just use it anywhere as an expression, it still is fine. You're still allowed to say this is a function, but it has no name. It hasn't been bound to anything, and so it's called an anonymous function. It's just gone as soon as you're done using it. And this is this map that we saw yesterday. They're often used as the inner part. The argument you send to the map is this inner function here, because you don't necessarily want to have to declare, oh, this is the function for the map right after it. This is the other function for the map right after this. So this way is like you're only using it for one purpose here, and that's for translating the items in this array this one time. So it's anonymous. It poofs into existence because you've declared it there, and then it's gone. Jaquay, we got everyone set up on the GitHub, and I think you should have an invite in your email. So if you accept that, and then we can get set up with the new repository. Yeah. Okay. So that's anonymous function. Does that make sense? It's a function. It's just the right side of the assignment. It's never assigned to anything. It just exists very briefly. Okay. This gets even more fun. If you take an anonymous function and then you wrap it in some parentheses, you still have a function which you haven't assigned to anything, but it just exists for a very short time, and then you put parentheses after it. It's just like running any other function. If you did increment, the function we made, and then the parentheses, the result would be to run it. Well, you can run one of these functions in the same exact way. So you just wrap it in parentheses, you put more parentheses after it, and this whole thing ends up evaluating all the way down to what the function returns when you run it. So that one's nuts. That one is going to take a while for everyone to get used to, I think. But here's a very simple one. If you have a function here, this is a shorthand function with the arrow function syntax, and we've wrapped it in parentheses, and then we've immediately executed it by putting parentheses after it and passing it a 5. This whole block here, this whole expression, is going to say, okay, I'm a function which returns whatever the argument is plus 1, right? And now I'm running with a 5, so I'm going to return a 6, and that value that's returned is the value of what this entire expression evaluates to. So the result will become a 6, and I will prove that. I mean, I know nobody needs to see this stuff like proven or whatever, but it's good to see the okay. Thank you. Okay. So if we something equals, and then we have this, a anonymous function wrapped up and then run right away, and the whole thing is going to be evaluated and then assigned to something. We have something is 6. Yeah. Sure. Yeah. It can be. You could put anything. This is you could say let argument equals 7, and then of course you can put argument in here. Oh, identifier something has already been declared. Oh, I already declared it with a let, so I have to just reassign something to it. But it works in the same way. Yeah. And we'll see a couple other examples of similar stuff. But that is that has a name, and that is this, and it is a mouthful. It's a very confusing piece. It's not used that often anymore, but it used to be used a whole lot for a particular purpose, which would be to have a whole bunch of stuff happen that's hidden from the outside of program, and then you could have the end result be whatever you wanted the public part of that expression to be. You'd return that. So you'd declare a function, you do all kinds of things inside of it, you'd return the stuff that you want to be public, and because of another thing we're going to see at the end called a closure, everything else still is kept inside of that, but only the stuff that you return is the value that ends up when you run it. Okay. So this is the property I was talking about earlier. This is why you can pass a function to map, and why you can return a function from any function. It's because they are first-class objects. They can be anonymous. They can be assigned to a variable and passed around like any other variable. So you can have 5. You can have the string hello. You can have a function that does something. These are all things you can assign to a variable name, pass it around, and then use it wherever you want. So that's called, they are first-class objects. They're just as, they have just as many options of things you can do with them as every other kind of object, every other type. Yeah, yeah. So the fact that you can pass a function to map is only because the function has the same abilities as a number or anything else you could pass to a function. Map itself is a special kind of function which takes a function, expects to be passed a function. And that gets crazy, but that's next week is more of that. Okay, so this is just this function. You can do this. This will be a function because we declared it here and we're returning it. So we can return a function from a function. Who cares about why? I don't even know why you'd do that. So there's a reason to do this. So okay, that's all the stuff we've already seen. So let's talk about more of other function stuff. You know, everyone is just like, I want to know more about functions. Can they do anything else? You know, it's true. Okay, this is just a detail. Every time you call a function, it's sort of like, remember we were talking about scope yesterday. There's like the stuff inside that function exists kind of in its own separate area, and it can see out, but nothing can see into the function. This is because every time a function gets called, a whole new context for variables to exist and for anything to be created or whatever is created for that function. It's like we're running a function. We need a whole new what's called execution context, and that is a big giant object or whatever it is that's pushed on top of a stack. And this is a very special stack. It's called the call stack. And remember, this is exactly the same as the stack we were sort of fumbling around with on Tuesday, but that is used in the same way here, because every time it goes into a function, something gets pushed on top, and now you're in a new context, and whatever context you're in is always the top thing on the stack. So it sort of makes sense as a structure. Every time the function returns, you're going out to whatever's containing it, so you're popping that context off of the stack. If you put like a lot of functions inside of functions, and you do this enough, I don't know how many exactly, it's quite a lot. Or if you make a function that calls itself, which you can do, and it does it too many times, there's too many new functions that you're executing, a function inside a function inside a function, you'll actually fill up this call stack. And it won't have any more space to put functions, and you'll get an error, a pretty obvious error in this case, that says maximum call stack exceeded or something, which means you filled up the call stack. You called too many functions inside functions. Here's a visual kind of demonstration of what a call stack is. This is sort of taken from the book. So let's say we've defined a function called greet, and it logs something and then closes. Great, we're not inside it. We haven't run anything yet. All we've done is declared a function. We've made a function exist. We're not running anywhere, so we're still not in a function by the time we get here. However, the next line, we are calling greet, so we're going to start running greet. So at some point between being on this line and being somewhere else, we're in greet. And this thing on the right here, sorry, we jump down. We've popped something else onto the call stack. This is a call stack, and these blobs are calls, I guess, whatever. They're contexts. That's what they're actually called. So we're going into the greet function. So we jump up here, we get this value. Whatever we passed in becomes this bound to this variable inside the context of this new function. And that has the name who. And then we get down to here, and console.log is another function. So we don't see what's inside this one because it's somewhere off somewhere else. But when console.log starts running, it has its own argument, and we're passing it whatever this evaluates to. And then there's another context, of course, that has to be inside console.log somewhere for it to run, right? Whatever that does, don't actually know, but eventually it finishes, and console.log will return probably nothing. I think it returns undefined. But because it's returned, now we pop off the stack. We're back to this end of this greet function. This doesn't return. Oh, is that coffee? Pause for cleanup. We'll be back to the.
So is there a number of functions that you implement within other functions?
Yes, that's what I was talking about yesterday.
Right, you said it could be up to 100.
The total, I don't know what that, and I don't.
I wouldn't do more than 50.
Definitely don't do more than 50, but that's because that would be impossible to even read. Like,
I can't even imagine why I can't even envision.
We'll see an interesting example in a little bit here. The computer didn't start throwing sparks into the air, right? I think it's okay. Okay. So we finish this greet function. It doesn't return anything. So really it's the same as kind of returning undefined. And so we're done. So we pop another thing off the stack, and we're kind of done with this line. So I sort of made the shading a little down, but we're out of that function. And then we immediately have another console.log, so we're going to push, and go into that context. And then we're finally done with that, so we're going to pop that. And so that's what the stack kind of looks like as you go through this running, and the yellow is sort of where it follows. And if you get into debugging, in a couple of weeks, there's like debuggers where you can actually do pretty much exactly this. You can pause the program anywhere you want, and you can say go next, and it'll highlight wherever you are. And you'll see it follow a very similar pattern. You can inspect the call stack while you're doing this. You can look into all of this stuff, but we're not going to really get into those details, just that this is a real thing. Okay. Another function thing is that you can add arguments to the end of when you're calling a function as much as you want in normal JavaScript, and that's fine. Like, it doesn't care. It just will ignore if it has 2 or 3 arguments and you pass it 6. It will just ignore all of the ones that it doesn't have a matching list position for when its arguments are listed. There's a kind of a magic like arguments object which you can look at to get all those other ones, to like find every other argument that might be there. It's rarely used. I don't really like the whole concept, but there's like a magic object for getting all the other stuff that you didn't have a named argument for. By default, Typescript is just like, no, you can't do that. This function takes 2 arguments. You can't pass it 6. And I prefer that for sure. But just know that, like, if you pass too many arguments, they might be in the wrong positions or something. It's not going to complain. It's just going to ignore everything after the first ones. So, for example, like this, you can make a function that called add. You pass it x and y. It returns x plus y. You can totally call it with 5 numbers, but it's going to ignore these 3 and return 3. And and let me demonstrate this one. I'm back in the card deck thing. Okay, this is slightly disorganized, but I won't check it in a GitHub. So we get 3 because it added 1 and 2. It ignored the rest. It didn't complain. Yeah.
Is that because like when we were doing the calculator and you said like so operators can only have 2, like it has to be between 2?
Yeah. It's more because like JavaScript adds an implied thing here that's like a special thing called arguments, and everything after this, if you call it with all of these, become an array of arguments. And it's so when you're adding it, the operator itself is only ever going to see 2 things, no matter what, because you're calling it with just an x and a y. So you're only ever going to be using those 2 arguments, but it accepts all the other ones just automatically because it has this magic arguments thing. The thing though is, if we go to this file, and I'll demonstrate, if we go to make it TS, Typescript, it immediately highlights this and says, expected 2 arguments but got 5. Like, thank you. That's kind of what it should have done in the beginning, but it doesn't. It just ignores them. Okay.
So what is the relationship between TypeScript and JavaScript?
TypeScript is sort of like extra stuff built on top of JavaScript.
So kind of like Sass is to CSS.
Pretty much, yeah. But it's it's called TypeScript because it has a lot more detailed type safety. So you can say not only is something an object or a function, but it's a function that takes this kind of thing and returns this kind of thing, and you can nest it as deeply as you want. You can be very specific with the exact types of everything, and then it goes through and checks it for you and tells you, hey, you missed an argument here, or you gave it the wrong kind of argument, or something. So it provides a whole lot of little benefits like that, and it's it's a Microsoft thing, so they are sort of attached to it. So there's a kind of a political business type of problem where it's like JavaScript is a standards-based language defined by many companies. Basically, it's just big companies who do JavaScript, or who get to decide what's in JavaScript, really. But they are all there. There's Google has a seat on the board, and everybody's in the committee. This is just Microsoft. This is like someone at Microsoft is like, and they'll probably end up standardizing this or opening it up because it is taking off. It's getting a lot of adoption. I hope they do kind of like make it into like okay, we don't own this one anymore because it's useful, and it would suck for it to just sort of turn into another Microsoft software battle problem where everybody has to deal with the fallout of their shenanigans, So anyway, I'm gonna cut off my ranting about politics or whatever the hell that was. Anyway, let's rename this back so we can do our other demos. But yeah, like that's what I was talking about. It'll get a little stricter, and some things in TypeScript it might say, I'm not even going to run this because this doesn't satisfy something that's stricter than JavaScript is. And in this case, that one, it's good that it does that because unless you want to use the magic arguments thing, this will just trip you up. You won't notice that something is broken until you get the wrong value, and that's no fun. Okay, so the other thing you can do is you can set default values for arguments that you want to leave out. So if someone doesn't pass, the second argument, then you can say what it should be. TypeScript does allow this if you use this newer syntax, which is it's a newer version of JavaScript, and it's basically you put the argument here and then you put just an equals right in line. So it's like you're assigning it right in line. So you could do y equals 5 too. But does that make sense? When you're listing out the arguments, you can put an assignment operator right there and assign something to them in the case that you don't pass anything in. So if I pass 2 arguments, then z will be assigned 5. If I pass 3 arguments, then z will be 3 because I've passed a z. Let's demonstrate. So we've added 1, 2, and 5 here. If we pass 3, then we're going to get 6. And if we do TypeScript mode, it doesn't care that we're passing 3 or 2 because it understands this to mean this is an optional parameter, and that's good. It's okay with either one. Sure, yeah, this could be, and this in fact could be hello world because plus is going to work just as well on strings. Yeah, all I'm talking about is the number of actual things you're passing it. Yeah.
And now, when there's nothing down there, then z is going to equal 5.
When there is 2 down here.
Oh, when there's 2.
Right, because this gets passed in as the first one. The first one's x. This one gets passed in as the second one. Second one's going to be y. Nothing is left for the third one, so it gets the default.
Okay, so 2 items.
Yeah, right. And if you pass 3 items, oh, it doesn't like this one. TypeScript is like, this one was a number up here, but now it's a string. I don't like that, which is also pretty nice, actually, in most cases. So if you make it a string, then it's going to concatenate all the strings because the plus will concatenate just as well.
What if you made a different string?
Yeah, so this will what? Oh, TS, I renamed it. Okay, so this will print the 3 that I passed it, but if I don't pass the third, it will print the default because this one becomes the default, the third one. Okay. So that's just optional function arguments. Sorry. The next thing is function recursion. A function can call itself. And if it does this too many times, it will fill up the call stack and you'll get an error. So here is like an example of a function that calls itself. So this is a bad, like there's no reason to do this. This is just a mistake. But if you call this once, it's going to say, I'm running. Oh, I should call something named this. And it's just going to do that forever. And it's going to keep shoving things onto the call stack until it hits the maximum size. And then JavaScript is going to say, you can't call that many functions. And it's going to stop it. So we see maximum call stack size exceeded. Let's see how many times it is. Let calls equal 0. Calls equal 1. Oh, sorry, not equal 1 every time. We want to say plus equals 1, or to add 1 to it every time. So we run it, and wait a minute. Oh, and we got to, so this is just going to error. So we got to do try. This is something you'll learn about later. You can say, you know, deal with errors however you want. This is a later tool. Don't worry about it. I'm not sure if this will work, but we're going to log it rather than just crashing. Nope, doesn't work. Oh, you gotta, so we're outside of that by the time we call it, so we should call it inside of that maybe. And I'm going to give up if this doesn't work because this is going off the rails. 15,667 functions, it looks like, which is probably like 2 to the power of something. I don't know. Anyway, yeah, so that's about as many functions you can call. It's pretty much only ever going to happen when you're doing something like this, when a function calls itself and it happens too many times. Now why, like, what's the point? Why would you ever do that? It's because you can do some interesting things. Like this is a pretty famous way to calculate Fibonacci sequence. So the Fibonacci sequence is you start with 1 and 1, and then for every number after that, you keep a sequence going, and you add the numbers before it, and that's the next number. So it's 1 and 1, then the next number is 1 plus 1 is 2, the next number is the 1 plus the 2, which is 3, and then it's 2 plus 3, which is 5, and so on. And this is a really clever way to compute it. You're computing it kind of backwards. You say, I want the 10th Fibonacci number. So I want to make a sequence out this many of these, adding numbers. And I want what is the number that you get to after 10 of those. So this function basically calls itself on the 9th one and on the 8th one, and then adds those together. Calling itself on the 9th one and 8th one calling itself on the 8th one calls itself on the 7th and the 6th ones, and so on, all the way back to it hits this case when it's 1 or 0. And then it all bubbles back out. So the call stack basically gets push, and the numbers drop down. You get to 1 or whatever you hit here. It's like, okay, I'm done calling myself. I'm going to return 1. And then that gets returned out, added, and so on. It pops everything off the stack, and then you get the actual number. So if we look at what this does, no, it doesn't do anything because I never called it. So if this should be 1, 1, 2, 3, 5. expected 2 arguments but got 1. Thank you, Typescript. This one's optional. You don't need it. This one is only used to save. So this one is efficient because it decides whether or not to recompute the same additions. Because what will happen is it branches out like a lot, and it computes, all the additions for the 6 Fibonacci number like 10 times, because every time one of the branches is asking for it. Anyway, because there's 2 calls, it branches out like crazy and then recomputes things. It might be computing the 3rd Fibonacci number or whatever in all different branches because it's doing that, and this stops it from doing that. I believe you can just delete this and delete this, and then it will be very inefficient, and it will call itself a lot more times and probably exceed the call stack much sooner. And that's really this is like the simple version. We got a console log it. Okay, so Fibonacci 5. Oh, Fibonacci 0. See, this is array index mode, so it's 0, 1, 2, 3, 4, 5. So that's the one. Now, if you try to do Fibonacci of like 100, it'll probably take a long time. And, gee. Yeah, so this is what happens when you don't save the results of the previous. It's probably recomputing what the 4th Fibonacci number is like, exponential number of times because it branches out like that. It's just going to run out of time. So if we do memoize it, what happens instead is it calls itself too many times and the call stack gets full and then it crashes. This one, gee, I don't know if this is ever going to finish. Yeah, let's try 50 maybe. Still pretty long. All right, well, we'll go to the next slide and see how long that one takes. Okay, so that's what recursion is. That's all. And there's some clever ways that get more complicated than this. This is another thing like those function expressions. When you start using them, it's like, expect them to be very confusing. They are sort of an advanced technique, but there are certain cases where it's like, oh, if you figure out how to do it with recursion, it makes like a lot of things, particular things, way easier than it would be otherwise. Okay, so there is another subject here. Functions with side effects. I can hear my computer fan starting to turn up. This is still cranking away. Hopefully we don't get to the next demo before this. All right, if a function causes something to happen that is affects the world outside of the function, and it's not, a function returns a value. Okay, sure. You call a function, you get a value back. That affects, you can continue using that value. But if it does anything else, if it goes out and changes another variable, which is a global variable, or if it console log, or causes anything else besides that to happen, that's called a side effect. In general, when you're making programs that have a lot of functions, you don't want side effects. So side effects are like the things you should sort of be very careful about. And I should say, like, when I say you don't want side effects, I don't mean you don't want any side effects, because if you run a program that has no side effects, then it doesn't do it. Like, you can't even tell that it's running or not. Like, that's how literally I mean. Like, a side effect is like printing something to the screen or downloading a file, or anything that is useful is itself a side effect. So this is somewhat like paradoxical. I'm saying, like, you should avoid side effects. That's the only reason you would want to make a function or a program in the first place. But what I mean is that you want to be very purposeful about what your side effects are. You don't want to just sort of have them happen. If there's a way to do it that doesn't have a side, there's a way to do what you're trying to do that doesn't have a side effect outside of that function, opt to not have the side effect, because then less surprising things can happen. You'll be able to think of your functions as completely portable. Anything that has no side effect, it's completely portable, and it's something where if you have found all the bugs in that one function, then it cannot possibly have any more bugs, because there is no interaction that is not input and output, and you know the middle is okay. So it lets you very much encapsulate and sort of solve things pieces at a time, and then not have to worry about them again. So yeah, console.log is a side effect. When you do document.innerHTML or whatever and change something on a web page, that's a side effect. Everything that like causes something that the user can see is a side effect, of course. Okay, so this is, whoa, okay, so that is 20 quadrillion or something. Cool. All right, so this side effect, this function has a side effect. What the side effect is we've declared a variable here called myNumber, and whenever unsafe operation, I'm calling it, it's pretty obvious it has a side effect. Whenever this runs, one of the first thing it's going to do is add 5 to my number. Well, because my number's out here, like, you don't know that the same thing is going to happen every time you run this. If you did an if in here, whoa, comment. If you did an if in here and you said if my number is greater than 10, console.log, like if something weird happens based on my number or based on something outside of this, then one of the problems with this is every time you run it, something different might happen. Depending on the input, or even with the same input, something different might happen because it's affected something outside of itself. So you don't really have like any way to like be sure what's going to happen when you run it. That's why these are things to watch out for. So if we run it right now, we get 8 because we're logging, at the end, we're logging my number. It started at 3. We pass in 1 to this function, doesn't matter. We're adding 5 to this this function, this variable out here. We're checking this thing, which isn't true yet, and then we're returning what we passed in plus 1. So we get 2. We don't even do anything with it. We could console.log it, but we'll see 2 every time because it's just adding 1 to the input and we're passing it 1. But every time we run it, we're going to see a different my number, and then sometimes we're going to see because it'll have gone greater than 10. Every time you run it, it's adding to this thing which is outside of the function. So I will add one more of these, and we'll see that happen. Nope, wait. We have to run it twice. So we run unsafe operation twice, and we log my number after each time. So we see 2, then we see 8, which is what happens when you add 5 the first time. And then we see the which happened because we tried to run it again, and in the middle of running that, now it's greater than 10 because we've just added 5 to it again. So we see that, and then we see 2 because that one's always going to come back as, plus 1. And then we see 13 because now it's different. We're accumulating this value outside of the function. It's not a parameter to the function, but the function is affecting it. And this can be dangerous because something surprising will happen because your function affects something elsewhere. I think I've sort of gone over this several times now, and you get the general idea, right? It's something that you can't predict because the function is reaching out and having an effect on the world, which is nothing to do with the parameters you give it or the return value that it's giving you back. And when you can avoid that, it's a lot safer to avoid that. Okay. Okay, so I think this is the last thing, and this is kind of a big one, but this is all for functions today. I know it's like quite a lot of stuff. Just, keep these slides, and, we might want to review them on the weekend at the office hours. I think that might be what we do, is like go over some of these things again in a, just a review format. And maybe like a activity or something, but a lot of it, I think it's stuff that we do want to be reviewing because it's a whole lot of brand new things which really don't have very much context yet. Okay, this is the last of them, I think. Yes, this is the last one. So when we talk about scopes, when we talk about execution context, every time you call a function, you get a new context for all your variables. When the variables are inside the function, defined inside the function, they're scoped to that local scope. They don't exist outside of the function. You can look out, you can't look in. Like, what is the kind of general, like, what does all of this mean practically for when you're using functions? Like, why is this significant? And one of the ways in which it's probably the most significant is that people toss around this word closures all the time. Oh, functions, this one's a closure. And it's always confusing to me. It's still to this day always confusing to me when someone's like, this one's the closure. Like, I don't really have a good connection between what I intuitively understand as what a closure is doing and the word closure. And I think actually very few people do. But what it is, and this you have to sort of slog through this explanation, and then, it's going to probably not make any sense, but the general sense of what this is will start to make sense as you use them. Functions basically capture any values that are created inside them. So when you call a function, and inside that function you define something, and then you might return it, or you might just sort of use it in some other, combine it with something. All of the values that are created, when you call that function, they're captured by that call of the function, and they're sort of saved away so that they can be used later. Like you can have a function return something which is bound to all of these things in that original context when it ran, and which is no longer running, but you can still kind of use, and it will still save kind of a memory of that. So when you use a function like that and it saves something inside of it that ran inside of it, and you use it later, that's called a closure. It's very confusing. I always get the details wrong. I checked this one against the book, and I think this is correct. This is all correct. But I'm just going to take the examples from the book, and we will just talk through them. So this is what I mean. This, someone might say, like, this is the closure, I think. Or this call is the I'm not even sure which one they'll say, probably at different times. But there's a closure here somewhere, and this function is involved in that closure because when you run it, let's say you run it twice, it's going to take the value you give it, it's going to declare a local variable, and it's going to assign the number you pass it to that local variable. So now there's a value that exists inside this function, inside this execution context. And what it's going to return is a function which returns that local variable. Okay, it's very convoluted, but this this thing here refers to this, right? We're returning a function which could be called at any time later. So if I say wrap value 5, it hands me back a function that says, hey, here's my return value. It's a function. I could go hand that over to another thing. I could put it in memory for a little while and then call it an hour later. You know, you can do whatever you want with that value in your program. But anytime you call it later, that function that it gave you, this thing, is going to remember what this was when you originally called this function. Okay. It's very sort of, it's a lot of stuff going on, but it's not bad. It means that when you have a function, and when you're calling functions, when you're saving stuff for later, you don't really have to worry about, is something ever going to over. It's called local in both cases in this one, in the context of the function that's executing at that time. But the 2 does not overwrite the 1, because they are totally separate contexts, and both of them are saved, so that when you return, the function that spits it out, you're going to get spit out 2 different things when you call those functions that spit it out, right? So we call this, we pass it 1. It saves this variable. It returns this function here, and that becomes assigned to a function. This thing is a function now. Same thing happens again. The function is returned. It's assigned to a different function. And then we call both of those functions later. This could be separated by hours or whatever. And no matter when we call them, they're both going to sort of remember what this was when it was basically passed out of this function. When this function was created, that's going to pass it back out. So it's really it's not very impressive, but this sort of means you can do this with any number of variables. You can rely on stuff not getting overwritten when you call functions many times that have their own internal state and variables and things going on. That's pretty much it. So we get 1 and 2 when we log what comes back out of these things. That one's quite a lot. There's a lot going on. One way that you might be able to use this kind of usefully, and this gets into sort of a kind of a functional programming pattern, is that you could make a function, and these are higher order functions, by the way, because they're returning other functions. You'll get to that next week. You can make a function called multiplier. I don't like that name because it's ambiguous, but when you call multiplier on a number, right, that becomes this factor. And multiplier will return another function, which I guess is a multiplier function, I don't know, which takes in its own number of any kind and then multiplies it by the factor you originally passed when you created that function. So if we make a twice function by calling multiplier with 2, we get passed back out the resulting function, in which factor is going to be 2, and it's going to stay 2 no matter how, what we do with it. So when we call twice anytime later on another number, it remembers that, oh, factor in when I was created, factor is 2, so that returns 10.
So if you changed 5 to 7, it would return 40.
Yes. So we get 10. right, we get 14. If we made 2 different functions, one of them is twice and one of them is thrice, we set those up by passing in 2 and then 3 as the factor. So if we log twice 7 and then we log thrice 7, we're going to see 14 and 21. So, these are saved pretty much forever, and we get these functions which have a memory of, this whole context that led to them being returned. That's it. That's what a closure is. You probably won't use anything like this right away for a little while. I don't ever really write a function. I think to myself, I'm writing a closure. Like it's sort of like just something you internalize about how the behavior works, and you get a sense of like when it's safe to declare a variable or not. It's safe to declare whatever variables you want in the functions that you define, and you can use them for whatever purpose, and you can trust that they're not going to be overwritten by something outside of that function. That's pretty much it. Okay. So that's all the things I have for functions. There is more some more clarification on the map and the stuff that we just looked at very briefly in some upcoming stuff. But this is most of what functions are, and everything else sort of is a use or an extension of this basic stuff. So I think again, it's something like, let's review in particular a lot of this stuff after a couple days. Maybe on Sunday if we do office hours, I'll set up a hangout and we'll probably just go over a lot of this stuff again. It's good to go over it again a couple times because it's sort of important, and it's very alien to most other types of stuff you've done so far with HTML and all that. Okay, so browsers. We haven't touched the browser at all this week, sort of on purpose. You're gonna get back into there's gonna be a lot more browsers. This stuff all runs exactly the same. If you type it into a file, it runs in a browser. The difference is browsers have a whole lot of other stuff that Node doesn't, and vice versa. Node has some features that browsers don't have. Like you can talk to files on your local machine from Node. You can't do that from a browser. But browsers have things like this document object model, which you've heard about. It's a document thing, and you can say get element by ID. You can run all these kinds of functions on it. It's all JavaScript, but there's all these parts that are sort of included in the browser environment, which we haven't seen here. So you'll see those again. They have that prompt thing we used yesterday. They already have that thing built in. One thing is that if you're using Google Chrome, it's the same exact engine is actually compiling your JavaScript down to all the way down to machine code and running it in both cases. It's the same software, so it should run exactly the same. They have different features, different attachments, because one is for running in a web browser and one is for running from your command line or your console locally. And we'll probably, we'll be using both of them. Node.js we're going to be using for a web server. We're gonna be able to write a web server that serves web pages, and it runs locally in the console with Node.js. And then the pages and the UIs and the things which move around on the page, anything in React Native, everything that sort of is the front end and runs in the browser or runs on the phone device will be also JavaScript, but that's going to be running either in Google Chrome or React Native land, which is some wacky stuff that I don't think anybody's going to get into. Like, it's something that, like, probably nobody who even uses it understands all of how that thing works. It's extremely complicated. It usually works well. Don't be afraid of using it, but it is a very complicated piece of technology. But it's using JavaScript, and it's using the engine that runs the JavaScript just the same as what we've seen here and just the same as what you see whenever you're in a browser. And maybe if we have time on the office hours, we can sort of go into like how that engine actually works and what it does if people are curious. I don't want to sort of overload with like, you know, this is what happens below JavaScript level right now, but if anybody is interested anytime, like we can do a session on that. Okay, so like again, don't panic. We are just learning the tools. This is just, we're talking about the tools. There's a lot of them. They're somewhat confusing, and it'll take a lifetime really to master some of them, or you know, many years. You don't have to master them right away. Nobody has mastered probably most of these tools who is in the industry. It's very rare to see someone. It's very, you know, to see someone who's like a master of a lot of these tools, and that's not, you know, that's not necessary. Everybody struggles with them. But you know, the programming itself that you're going to do is a craft. You have to practice it. You have to do it enough for this stuff to start to click. There's no way to sort of explain around that. And I think like it might feel like this is not how you're like, there's no way I could ever get comfortable with all of these concepts. But that's like that's how everybody feels when they see something like this. And usually people don't see this much of it this quickly. Like you're sort of in an environment where you are doing a lot of it pretty quickly. So, you know, this is not, I didn't know anywhere near this much stuff about JavaScript in the first week or two that I was using it. So, you know, kind of be a little easy on yourself if you feel like that. There's more things, there's more features, there's more tools. I think it might back off a bit because there's only going to be a couple of major, there's some major things happening next week, but there's going to be incorporating back into the browser either next week or the following week. And I think I talked to Max, he's good with using GitHub like we're using it for next week at least. So hopefully we're good with GitHub, so that's good. No. I thought it was the next chapters in I thought it was, you know, there's going to be I don't know if Max is going to follow all the chapters in this book, but there's going to be, you know, array stuff. Some of the array stuff we've seen. There's higher order functions. There's a lot more on objects and like just how to use objects. There's probably going to be a project day or two, but I don't know if it's this project. I know Max is using Free Code Camp, so a lot of the exercises will be through Free Code Camp, and I think some of the, you know, you'll be able to follow along there as well. Okay, so does anyone want to break a little early today, and then let's get right to the end of the card trick project? Sounds good. All right, I will pause the stream. Sorry. The homework is here. There's some exercises at the end of chapter 2 and 3. I really recommend all of them because like this kind of thing, it's not even so much for like you should solve them, but like you should try to solve them, because this is how you're going to start getting the hang of like just looking at a problem and having a blank piece of sheet of VS Code or whatever and starting to write things. I mean, this is, and the problems are designed to have. Are you editing my file, Jeremy? Are you editing the file? It's yeah, they're designed to be sort of encapsulated smaller project problems, but interesting problems and stuff where you're not going to use any of the fancy, you're not going to need closures or any of that crap to do them. You'll be able to do them with loops, you'll be able to do them with, you know, some of the much more easier stuff to understand alone. And the idea is just to sort of try to get a sense, how do you model the problem? How do you do it? I would say try to spend at least half an hour on each one without looking at anything but maybe the book or slides. Don't look at the hints and don't search for the answers for like half an hour to an hour. And then if you've solved it, great, that's terrific, but don't expect to. Like expect to, have some trouble. And the point is that once you see how they're done, all of the work you did trying to do it will actually start to click together. And that's the assignment. There's another article, which is extra credit, and I think this thing is one of my favorite like blog posts of any kind. It's sort of an interactive blog post. It uses JavaScript to animate things, and it talks about abstraction and programming little robot cars and stuff. So I really think this thing is terrific. I can't recommend it enough. It's not, I don't know how to grade it, but do it. This is great. Okay, that's it. Break time. do a little bit of maintenance here, or house cleaning, whatever you'd call it. I did. I just started the stream again. Hello, internet. Hopefully. So there's a couple little things that I have skipped or forgotten. The first is that when you do an and or an or, and you put something on the left and you put something on the right, something on the right could be a function. It could be like a value that's result of running a function, or a function expression or something. And if the value on the left is good enough, in the case of the or, if the left-hand side is true, it knows it doesn't even need to check whether the other one is true, because or means either this thing is true or this other thing is true. It checks the left one first. If that one is true, then it doesn't bother to even check the right one. And in the case where you've given it like a function or something as that should evaluate by running down to that, it's not going to run the function. So you can cause like different functions to run or not run with a nice little shorthand by having it fall through to different cases based on how you can just use an or. You might see an or as a shortcut for saying like check something first and then run something if this thing is true. Does that make sense? Okay. So the or operator that takes two values or two expressions, two things that can be turned into values, and it goes in the middle of them, and it returns true if the left thing is convertible to true, or the right thing is true or is convertible to true. Does that make sense? I mean the number, like if we saw if we go to node directly and we say 1 or false. 1 is convertible to true. Any number that is not 0 is convertible to true. Okay? False is not. 0 is not. False or 0. Okay? So, but this one prints 0. Interesting. Anyway, it's only going to try to test the right-hand side if this one doesn't convert to true. Okay? So if this one converts to true, then the whole thing is true, right? True or false is true. 0 is not considered true, but true or 0 is true. Because 0 or false will be false. If you do true or console.log something, it's not going to log, because true is true, and it checks them left first and then right first. And it's already got enough to say the whole result of this expression is true, because that's what it does. Either one, at least one is true. It's good enough. It doesn't even need to see what the thing on the right-hand side is, so it doesn't need to log. If you do it the other way and put it on the left, it's going to run it. See, it logged it here. And then it returns true because the other side was true. And it's like, okay, but it had to check both sides, because console.log, when you run it, it doesn't return a true or anything that can be converted to a true. Okay, so that's all. That's what that is. That it basically means that anytime you might see a function on the other side of this or statement, it's only going to run if it needs to run, if it actually needs to check that value. Does it make sense? Okay. And the other detail is that comments are a thing. I didn't even mention that comments are a thing, but there's comments. You've already seen this. You've probably gathered how to do them. it is the 2 slashes like this. It turns green in Visual Studio Code. There's another way you can do a whole bunch of comments at once. You can do a slash and then a star, and then type whatever you want. And then as many lines as you want, and then you can close it by doing a star and a slash like that. So you can do a whole big comment if you want to write a whole paragraph without having to write these things on every line. That's it. Right, yes. That's true. Command backslash. Nope. Command forward slash. And that comments it even more, but whatever. I think it will always prefer to put the comments on every line though. It won't wrap it automatically. I don't usually wrap anything automatically.
Well, you have a hard break between those 2 lines, so
It always puts it on every line, which is fine. I mean,
even if it's a continuous wrap without a break at the end. Try it.
you mean just a very like word wrap?
Yeah, like if it's set to wrap.
So mine is set to
So
scroll.
now go up to view, toggle word wrap.
Yeah.
And now highlight it.
See how 92, this is all still line 92, so it's just going to comment one line. Which is all 3 of these here are line 92, because in reality it's all off the end of the screen, but it's wrapping it for you.
Right, but it didn't put it on the 2 separate lines like it did.
But they are not 2 separate lines.
That's what I mean. So as long as you don't have a hard break in there, it's not going to put the comment.
Yeah,
backslash
yeah.
in front of each.
Right, okay. Yeah. But it won't wrap more than one line either in like one big comment. It'll always do 1 per real line, not the ones you see, but every number on the right side will get a comment slashes. That's all. Does it do the star? Does it? I don't know anything that makes the star automatically.
I don't know. I mean, we can try just write 2 lines or whatever, however you want to do it, whatever.
Whoops. It thinks I'm writing JavaScript. And then
So I highlight it and then I hit Command and then KC and it comments it out. Oh, so it did. Yeah.
okay.
And then
Anyway.
if you do Command KC again, it'll undo it.
Nope, it added more. What about KU? Yeah.
No, it always.
KC. I'm doing KC and it's adding it every time.
So Command KC is not a toggle, is what you're saying?
KC is comment it more, I guess. And KU is always uncomment it more.
Whereas the command / is a toggle.
This is toggle. Yeah. Okay, good to know. That's all. Comments are useful, and hopefully these ones are clear enough. I mean, let me know if any of these stuff we've done is still confusing. I'll do the same thing with the code we're going to write today. Yeah, and then we should have our whole card trick in about an hour. So as long as I remember to bring my paper here. So we're going to finish out this, and then we might try 1 or 2 improvised changes, but the rest of it will do the complete card trick at first, and then see how much time we have. Okay. Prompt for row index. Oh, I took out, yes, I deleted this, because this was just a way, I guess we'll check that I'm going to close my node, and I'm going to run index.js, which is where I'm working. So this prompts for the row index, and it continues prompting no matter what until you pick something 1, 2, or 3. And unfortunately, Control-C doesn't work either now, because it's like, oh, I'm prompted, that's your key, and that's kind of bad, but we're not going to worry about it right now. So just to get it to close, you got to type something between 1 and 3, And hopefully, if it really gets stuck, if you made different code and it never is okay with it, just close Visual Studio Code and restart it. And it's kind of brute force there, but I don't think we have time to go into key handling and Control-C, escape keys and such. All right. That's more of a Unix administrative thing anyway. Okay. So we have this prompt working, and if you remember, we have the render working. So we can, at the bottom, we can say render card rows and pass that a deal card rows, which is the first function we made. And if we run this, we're going to get our 3 rows of cards with the nice symbols. And then it returns undefined. I don't know why that's undefined there. So we have the 2 halves that are the basic pieces for, yes. Make the text bigger or smaller? Okay. All right, so we have the 2, is that enough? Okay. We have the 2 halves. We have the printing out the cards. We have the getting the only input we need, which is the number that the row is in. And remember what I was talking about with side effects. Both of these have some side effects. This one's going to pause, and it's going to wait for input, and it's going to do something depending on that input. So this sort of causes all kinds of, a timer to go off somewhere deep in the program and stuff. Other than that, actually, it doesn't really have a lot of side effects, but it's getting values from something other than its input. So it's something, you definitely want to be aware of. On the other half, when we render, this one has an obvious side effect because we're printing out to the console. So like thinking about these and just being aware that like we want the side effects here. We do want them because without them, we don't have anything useful. It's not going to show anything and you won't be able to tell it what row it is. So we need these side effects and we need to keep them. All the other stuff hopefully doesn't really have any side effects, except for start the program, or I guess that's not really, yeah. So we don't really need any other side effects except those if we do this right. Okay. So the thing about the thing about this trick that's a little interesting is that we need to be reorganizing the cards every time. So we're going to have to loop through this process of display the cards, person selects which row it's in, and then we reorganize the cards and then display them again. We're going to have to do that several times. So the next thing we're going to need is a function that reorganizes the cards. And I'm going to demonstrate just what the reorganization looks like on its own with the cards real quick, and then we'll do it. So we have 3 piles of 7 cards. 1, 2, is that 4? That's 7, and then 3. Okay, we have our 3 piles, and they're displayed all out so you can see every card. You choose the one pile that it's in. Let's say it's this one. What we need to do is take this pile of cards, put it between the other 2, right? And then we need to deal into 3 new piles. So I guess you get the idea. I'm not going to deal the whole thing, but we need to sort of go from the top and start reshuffling them into new piles, which are based on going alternating one at a time. Okay. So we need a function that's going to take our. Whoops! I just taken a photo. Okay, great. We need a function that's going to redeal these cards into their new rows, and we'll call that. I'm going to delete this console.log. We'll call that function redeal card rows. And in order to get the new rows, we have to pass this function the old rows, and we have to pass it the row that the person selected, so it knows which one goes in the middle. And we're going to make both of those arguments, because again, we don't want it pulling it from some random global place. We want it to be passed in as arguments and have the only things that this function does operate on those arguments and return it. So it's very predictable, no side effects. So we're going to have card rows selected row index are our two arguments. This one is going to be an array of arrays, because that's how we have it. And then this one is going to be the index, not the number 1, 2, or 3. It'll be 0, 1, or 2, which is the array index that the person is selecting. Because we've already taken care of that in the prompt. See, we've subtracted the 1 just previously. And we're back in computer land. Numbers start at 0. And this will be that index. So here's how in JavaScript that you would pull out. We need to basically pull out the one row they selected. We have an array of 3. We want to grab the one that they've selected and put it aside, because then we need to reorganize it. So we can say const selected row. This will be a variable that holds just the row, the array, for the row that they have selected. And this will be, the value of this will be card rows. This is an array of arrays. And the array, oh come on, I don't have, the JavaScript helping has failed, and I don't have any IntelliSense. This is a common thing. Oh wait, it doesn't know what card rows is. It doesn't have enough information to tell what card rows is. I haven't told it that it's an array of arrays. So unfortunately, we don't know what methods the arrays have, because it doesn't know that it's an array. That's too bad. But just trust me that arrays have a method called splice. And oh, now it's figured out, okay, you're going to try to do a splice, and it's way up here for some reason, but it's printing out part of the help text. Oh man. It's really flake. It's really just sort of, okay, well, it's telling me what the arguments are for splice, and they're correct. So the first argument to splice is the index, where you want to start splicing. So there's two methods like this on every array in JavaScript. One of them is called slice, and one of them is called splice. And what slice does is it says, you say, I want this array from position 4 to position 6, or from position 4 to the end, or whatever it is. And it will return you an array that just has those items that you wanted. Not the whole array, but a new array, a copy. It's always a copy with just those items. And it will not alter the original array at all. So if you say, I want to slice this and get me 4 of them, the original array that you called slice on is not changed. It still has all of its original stuff. A brand new array reference is created, which points to just those items you wanted to slice. That's how that works. Splice is a little different. What splice is going to do is actually say, the number that I pick is going to be selected row index. And we want 1, because we want just one row, the selected row. But splice is actually going to say, make a new array, take this item that's at this position, and only one of them, because we say only one, and move it into the new array, but also remove it from the old array. So it's going to modify the old array. And usually you want to be really careful with like things that mutate values and stuff. That's a sort of a more dangerous thing to do in general than always sort of making fresh stuff and basically wasting computer memory, but making it more predictable. In this case, we totally do want to remove this. Yes.
Does that just prevent it from grabbing the same thing more than once?
Define.
Like, so if you're asking it to splice, right?
Yeah.
To remove it from the original array.
Yeah.
If you didn't splice it and you just sliced it, would that the original value
It would still be there.
The original one, and then there's a chance it would take the same thing again.
Sure. Yeah, it would be the same thing again if you sliced the same index
So
over and
that's why we
over.
use splice instead.
Well, if you actually want the original array to be modified so that the next time you look at it, it's gone, then you use splice.
Right.
If you want it to stay there, but you just want a window into what it has, you know, a little piece of it, then you use slice. We definitely want this to be gone from the array because we don't want to have four. We don't want to end up with 4 piles in any way. We just want the one over here and the other 2 still here. So we're going to use splice. Splice returns an array. Both of these return a new array, which is 3 things long. And we know there's only one thing in this one because we just spliced one thing. So we're going to immediately use the 0 index to say, just give me that one thing out of the array. Okay? So this will be just the row array that was selected, not the slice of all of the rows, which is an array, another array. Okay. Now that we have that out, we have an array here, which is our selected row. And then we have an array of 2 arrays, which are our other 2 rows. They're still over here. And they're still in card rows, which we've mutated. That's a side effect, by the way. This is actually a problem because we sort of technically do kind of have a side effect. It mutates whatever you pass it. That's not good either, but we'll ignore that for now. Okay, so now we're going to make a new pile of cards with the selected row in the middle. That's pretty simple. You do const pile of cards, and this is going to be an empty, a brand new array. And I will open up some new lines here. So we have card rows has 2 items in it, and we have this other third thing. We're going to use this spread operator, which we saw very briefly with objects. For copying objects, this takes all of the things inside something and spreads them out into a new thing. So instead of getting a nested array in here for the row, we're going to get all of the array's items, just all of the items inside the row. That's it. This, yes, that's the spread operator. So that takes, this is our first row. So this is our first leftover row. We only have 2 things now. This is our first leftover row because we're using the 0. And this is taking that leftover row and spreading all of its items out into this new array. We want that because we want everything in one big pile of cards. So we have this. We're going to do the same spread operator on our selected row. And we could put the 0 here. We could move this 0 down here. I'm not going to, but you could put it either place. It would work just as well. Because both, you know, the selected row, when you name it a selected row, that's why we pulled it out of the slice, because you know you want it to be one row. You know it's always one row. It should be not an array. It's not an array of arrays. And then after that, so this one's in the middle now. This is what we want. After that, we do card rows 1, the other thing in card rows. We know that there's only 2 things in card rows. And there they are on either side of the selected row. All 3 of them are spread out into this new array. So this new array should be a pile of cards. It should be a big array with 21 cards in it, and that's it. So let's we can pause here, I think, and test that this is what happens. This is probably a good point to pause and try it out by doing just console.log pile of cards. we add that here, and then after everything, okay, we need to get some card rows, and then we need to redeal them, and we need to, that's all we need to do, because redealing them will have a side effect here of logging, which is what we want. So we need to do redeal card rows, and we pass that deal card rows, and the second argument to redeal card rows is which row index we picked. So we'll say we picked 1. It doesn't matter. It has to be 1, 2, or 3 though. Oh no, it has to be 0, 1, or 2. It's the index. I just caused a bug. Except I got lucky because I picked the one that's also an index. I will say 0 to make it very clear. Alright. So if we run this, we should see at the bottom just like we expected, one array with a whole bunch of cards in it. And who cares? I mean, like, they're reorganized in the right order. You can check that by like checking it before you redeal and then after you redeal, and comparing the two arrays. We're not going to do that right now, but we're getting the right shape of data, so that's a good sign. We have 21 cards in a big pile. Okay, so I'm deleting that. We're done checking here, and I'm going to commit to GitHub. Not this one. This one's gone. Undo, delete, yeah. And then commit message, part lay through redeal card rows in 21 card trick. And pull, pull. This rebase one is slightly different. I think it's okay if you do it by accident. And push. Okay, so that's all up. Now, we have a big pile of 21 cards. The next thing we have to do is deal them into 3 piles from the top. So we need to go take off the top of this array, whatever that means, and put the first one into pile 0, the second one into pile 1, the third one into pile 2, the fourth one into pile 0, the fifth one into pile 1. We need to continue doing that. And in order to do that easiest, we're going to use what's called the modulo operator. It's another new operator. This is what I mentioned briefly earlier, is sort of like the remainder in division. And that's exactly what we want. We want to divide these cards into 3 piles, and which pile it is, as you're dividing, is going to be the remainder of that division. If you divide 7 by 7, you get 1 remainder 0. It's pile 0. If you divide 8 by 7, you get 1 remainder 1. It's pile 1. If you divide 9, sorry, not by 7. I'm sorry. We're dividing by 3. We have 3 piles. We're dividing by 3. It's still the remainder. So 7 divided by 3 is 2 remainder 1. Pile 1. 8 divided by 3. 2 remainder 2. Pile 2. 9 divided by 3. 3 remainder 0. Pile 0. We're back to 0. So it loops around exactly like the remainder does. And that's what we want here.
And you're going to comment the sections.
Oh, yeah. So first we set up an empty array of 3 arrays. These are our new rows. So we do array symbol, we do another array symbol, that's the first row, another one, the second row, and then a third one, the third row. They're all empty, but that's the shape, that we have the shape. And then we need to go loop 21 times. This is pretty easy. We won't use any of the fancy function loops this time. We'll just do a regular for loop. So for let I equals 0, I is less than 21. Now because we're starting at 0, once it's at 20, you've looped 21 times. You got to remember that. So less than is usually what you see here. And then I++. That's going to loop 21 times, and each time I will be one of the values of an index into our big pile of cards. So we only have to do one thing in here. We have to take the card and put it into the right place in new rows. So we do new rows. The index we're putting it into, the top level index, the new rows is an array of 3 rows, and each of those is an array. So the top level index is the row we're looking for. It's the remainder. We're going to take I, we're going to do the modulo, which is what I mentioned, is the operator in question. And we do a 3. That's it. So this is going to do exactly what we described. 7 modulo 3 is 1. So this will, deal exactly like what we need. So now that we've got the row we want here, we can do dot push, because that row is an array as well. It has the push and the pop, these methods, and we're pushing the cards onto each pile, 3 piles. And what we push is the thing at position I in our pile of cards, because that will go through the pile of cards in order as we count up I. That's it. So after we do this 21 times, we've dealt all of our cards from the one big pile into the 3 new rows in the way we want. And because of this thing with the putting the selected row, pulling it out with the splice, putting it in the new pile in the middle, we've done exactly what we needed to. We took the pile, we put it in the middle, and then we deal just 3 rows. So all that's left to do is return the new rows. And that's it. That's how we redeal the card rows. I think it's kind of a lot of work to test this one did the exact right thing. You kind of have to compare it with cards or just look very carefully. And that will probably also take a lot of time. I guess we could do that. I don't know. Do people want to bother with that, or should we skip it? Like check that this, check the accounting and make sure this is really dealing the way that we think it is. I'm pretty confident that it is. And really, what if I was doing this for real, the only thing I would check is that it outputs something that's the shape that I think it should be in, And then later, if it doesn't turn out to work, then something, you look further, I guess.
And by the shape, you mean the 3 rows?
I mean an array with 3 rows inside of it. Each row is another array. Each one has card objects in there. Make sure all that's there. So I guess let's just do that much. We want to do console.log redeal card rows, deal card rows. Selected index is 0, and that's it. So we're going to deal card rows. You see how I'm kind of reading this from the inside out, because this is the order in which these functions are going to run, is from the inside out. We deal card rows, that gives us some fresh rows. We pass that and the index 0 to redeal card rows. That's going to run and do what we just wrote. And then we console log the whole thing. Well, it looks like we have an array of arrays there, and each one has about 7. I think we're good. Okay. Redeal card rows, deal card rows. So somewhere along the way, I think you're calling a render.
I think it's a problem with my curly braces because we have one.
save this in another file, like to compare later,
Okay.
and you could get the. If you want, I can push this up. I'll push this completed function up right now. Completed redeal card rows function and 21 card trick. Pull, push. This part is very straightforward. Okay, so we have basically one function left to add, and that is the function that does the whole trick, because I think we have enough. We could probably break out some other pieces, but let's just write the function that uses all of this other stuff, puts it in the right order, and it does it start to finish. So this one will be called function do the trick. And it takes no arguments because it sets up everything it needs and it prints out everything it needs. I don't think it returns anything either. It's all side effects. This is the whole thing that just interacts with the user and does the whole trick. Okay. So the first thing we're going to do to set up, obviously, is we need to start our card rows. We've been doing this in every console log, but let's just save a variable that will keep our card rows for the whole trick. So we'll say let, because we might want to change this as we go. Card rows equals deal card rows. That's how we got them, the initial ones first. Okay, so the way that the trick works is that you need to deal at least twice. So no matter which pile they say, even if they say it's in the middle pile, it could be at one of the ends of the middle pile. So to get it to go into the middle position, which is what we want, which is how you can identify the card just by picking the piles, we need to always loop at least twice. And then the way it works is after that, after you've always looped at least twice, the next time they say that it's in the middle pile, it's in the middle position. So we need to sort of have a way to represent all of that in code. And I almost think like we should have a whiteboard here, because this would be a really good thing. If you're doing this kind of problem and you don't know where to start, this is a really good thing to flowchart. This is like a classic, and I should have made a flowchart, but there's a whiteboard right here. The internet people will have to, I'm going to just do it real quick. Let's see. Photo booth. This is working all right with the, look at that. Technology. Okay, so we have start here. You can say start if you want. The first step we get to is have we dealt twice? Right? You check that. If we have, will we continue on? If we haven't, we say deal and prompt, right? And then we go back to here. This is no. This is yes. So this is a nice, it's like a visual way to sort of start. You don't necessarily go right to making if loops and everything, because as soon as they get above a certain, scale, you're not going to be able to keep it all straight. So this thing is a lot easier to look at a very big chart and just follow it through. It's designed for that. So if no, we deal in prompt, we go back. And they've entered the prompt, and we redeal. That's all sort of implied. Redeal, reset. If they say yes, or if we've dealt twice, if that's true already, then we go to this second bubble, which is deal, because we haven't dealt, like we only are dealing here, right? We need to deal one more time to show them the cards. And we need to then go to, is it in the middle pile? And if that's yes, we're done. That's how it works. We know which card it is. If we pick the middle card, whatever it is, we're done. If no, then we've just dealt, we need to prompt and check. Okay, we're not going to deal right away because we might be all good. We ask again, is middle pile? And if they say yes, we're done. If they say no, we prompted check, and deal. So actually, I guess you can sort of start seeing how you can group these things together. If we have not dealt twice, we're going to do all of these together twice. We're going to deal, prompt, and then redeal based on what they needed, or what they said. So this always happens twice, the same three things. We can group those. After that, we're going to deal again, and then there's a different kind of pattern. We dealt by itself, and then we're going to prompt. Sorry, this is prompt. I've got this a little wrong. See, this is what, this is why this pays off, because then you don't have to stare at a bunch of ifs and elses and try to figure it out. We're going to prompt, prompt. And if you properly did this, there'd be quite a lot more bubbles just for this simple thing. But we'll say this one's prompt, and then is middle file. If no, we already prompted, so we're going to this is nothing. Well, we're gonna redeal. Reshuffle. I shouldn't have called it redeal because it's really reorganized. We're not dealing. Dealing is one thing. Reorganizing is one thing. Prompting is one thing. And I'm making this confusing by calling it deal because it's not deal. It's there's like something going down outside. Okay. Anyway, you get the idea. I didn't really get that ready, so it's somewhat messy. But you want to start there as soon as it's this complicated.
So you would probably use that to use the same language in there as you would in your comments to help you construct your code.
Yes. So when I'm doing it, I didn't actually do this step this time. Right. If it's something more complicated, I will totally go do this step on its own and sit there and cross things out. But
and that's what I'm thinking, because like a lot of this is like another language to us.
Yes.
Maybe to start there so that we can like figure out what to do as far as our code.
Yeah, I mean, I think that's like something that like you're gonna have to start with simpler problems than this one, because this one is not something I would expect anybody to be able to sort out on their own. Like this kind of thing. Like even with, maybe after a couple of sessions of this, and maybe we should be doing some classes on just this kind of modeling, Anyway, like I think like once if you want to take a crack at like the FizzBuzz problem or the other problem in the homework, if you get stuck, try doing it like this first. Doing it on pencil and paper with arrows and bubbles, and see if that helps you, and then we can probably review that on Sunday.
I think what that does is that actually just having it in the English language gives it
Yeah.
before you
Well, and the
start
arrows,
generating the code?
the arrows are universal. They're like,
Right.
go this way, go this way. You can see the control flow. What we call the control flow, you can actually see it and follow it like you would a path. You know, it's much more intuitive, and you know, it's obviously it's easy for like ambiguity to sneak in to here. Like I made a bunch of mistakes right away, where deal is this, and you know which one is actually a thing, and that'll still get you, but um, it'll help you kind of realize either when you look at it and the diagram isn't consistent, or when you try to start programming it and you're like, well, this step means two different things, or something like that. But in either case, it's going to help. All right, so we can start. I mean, this is roughly correct. So, you know, we're going to deal twice. We're going to deal twice. Like this, we don't need to like check, have we dealt twice, or actually we really do, but we're doing it with a for loop. We don't think of it that way. So we just say for let I equals 0, I is less than 2, because we're counting to 2, starts at 0, I plus plus. We're going to do two things. We need to deal, this should be render and prompt. Render card rows. That's the first thing we do. Oh, we have to pass this what we're rendering. Card rows. And then we know we have to prompt right away, and then we have to redeal right away. We know we're going to do all of those. We can do it all in one line. We can say card rows are going to end up at the end of all of this equaling redeal card rows. We pass it the current value of card rows because it needs to know which rows to work on. And then the second argument is the result of prompt for row index. We can run it right here. We could do all this right away in one line. That might not be that helpful because we've seen it wraps around, and you know, technically I think it's still less than 80 characters, which is what a lot of people try to keep lines to, but it's a little much to look at. So we'll pull this out of here, and we'll say const, because this will be different every time we run the loop, but we are in a block scope. No, sorry. Yeah, if it's in here, we should be able to do a const because we're in a block scope. Const is block scoped. Every time through the for loop is a different scope. I don't even know. Let's see what happens. We're going to say selected row index equals, when you prompt, you get back the selected one. And then we'll pass those two to here. We're setting card rows equal to the result of running redeal card rows on the original rows and then passing it what we just prompted to get. So we shouldn't need to test this with the console log anymore because render is actually printing them out to the screen and prompt is actually prompting. So we can start to interact with it right away. So if we go right at the end, now remember this whole thing is in a function, we got to run that function. So we'll say do the trick at the very end, and that's it. So we'll start this up. We render the card rows. It's running prompt for row index right now, and it's waiting for us to type something in. So it doesn't matter what you say. I'll say row 1. You hit enter, and this is good. They changed. It redealed the card rows, and then we've looped through again, and it says which rows your card in. So we're back here. Let's say if I pick the ace of hearts, it's now in row 2, and then it quits.
Now you need to do something else. Now
Right, so at this point, we've only looped twice. It can't possibly be enough times. We have to loop at least one more time, and then the next time it's in the middle, we're done. That's how it works. So first of all, we render at the top of this loop. We render at the very beginning. So at this point, we've just redealt, and we need to render right away. So we're going to say render card rows. Pass it the card rows. We're going to carry this variable along. This always has our current card rows. Now, we need to loop as many times as is necessary. And I don't know what the mathematical maximum, it's probably only possible for this to happen 2 or 3 more times at most. But we're going to just say loop while they have not selected row 2. Because they have to select row 2 before the trick can possibly be finished. So we're going to say while selected row is not equal to 1, which is row 2. Sorry, I shouldn't have even said row 2. I should be talking in computer array numbers. 0, row 1, row 2, you know? This is row 1, is the middle row. While that's not true, we need to save a variable that is the selected row. So I think what we want to do is make this variable outside the scope of the while loop, because we're going to want to check this every time, and we need to we basically need to keep it what it was on the last loop in order to check it the next time around. This is, I think, something I figured out in the process of working with this and moving this code around, and I don't know if I can trace exactly, you know, how I got to this needs to be outside of the while loop. I'll try to think of the actual process, and if we do an actual flowchart, maybe we can try to do that exercise also in the office hours if you prefer. But for some reason, we need to remember what it was on the last loop and check what it was, because the order works better like that. And I think it might become clear to me, but we're going to declare this selected row outside the scope of the loop, and we're going to be checking this value. It definitely does not start as 1 because it starts as undefined. It's not assigned anything. And every time through the loop, the first thing we're going to do is prompt. Because see, we just rendered. So the next thing after render, we know we have to prompt at least one more time. Sorry, and we're going to set selected row. This is for holding what they select. Okay. When they select, we're going to redeal, and then we're going to render, and then we're going to go back to the top of the loop. Because they have to select row 2. Wait a minute. This could loop an extra time. I could have just noticed. I think I got this thing wrong, the exact thing, and I think it loops 1 too many times. The trick still works, so let's just finish it, but I think I got it wrong. We'll have to fix that. We're going to redeal card rows. Because we've just prompted, we're going to redeal. And then we render. We always do those in the order. At this point, like any time after, while it's going through this loop, it's doing everything in the right order. But as soon as they say it's 2, we have enough times. We have gone through enough times. I think we've gone through. Yes, yes. When they say it's in the middle pile, which is index 1, then they're done. Then we're done. And I think we do it 1 too many times here. But we know we're done at the end of this loop. After this loop, we're done. So we're going to say const user card equals. At this point, we have the card rows. We know it's the middle card in the middle pile. We're going to say it's card rows index 1, that's the middle pile. Index 3, that's the middle card of 7. So it's 0, 1, 2, 3, 4, 5, 6. And then we're going to log it. Console.log your card is. We will interpolate and run card to symbol. Remember, we made this little helper so that we could show all the symbols last time. And we're going to pass that user card. So this should print a string that says your card is, and then 7 diamonds or whatever it is. And that's the end of it. That's the whole trick, apart from possibly that mistake, which we will come back to. Let's try it out. Yes, those are those. Anytime you're using string interpolation, this special drop a variable in the middle of the string thing, you use the backticks. I'm gonna close the shade before we do this because I keep seeing just police sirens, light is distracting my brain. Anyway, all right. Which row is your card in? Let's say this thing. Yeah. Let's say we pick the 10 of spades. It's in the corner, bottom corner of row 3. So we say 3. Now we find the 10 of spades. It's here. It's starting to move toward the middle, which is this. It's going to end up here. So it's now in 2, but we're not done yet because we've only looped. This is the second loop. We haven't finished looping twice. 10 of spades is now back in row 3. So we're going to say 3, and it crashed. Yeah, I must have typed this wrong. I know there's something wrong about this. Oh, okay. Well, this one is okay. It still should work. But what I forgot here is you have to pass render what it's got to render. So this was the first time we got down to this point in the loop, and it crashed because I did not pass it the cards. Now, if you're doing like a function you intend to use for a long time, it's probably a good idea to the first thing you do in that function is check that you have the cards that you are given, and then have it like return an error that says I need cards rather than cannot read property for each of undefined, because that takes a longer time to understand what the heck it's telling you. Yes. Okay, so which row is your card in? Let's say corner again, 8 clubs. That's in 3. It's in 2 now. It'll follow the same pattern because all this it's shuffling the same way every time. So 2, then it's back to 3 at the bottom there. And now it's where we want. It's in the middle position in 2. And it says your card is ace of clubs. So the computer can do a magic trick, which if anyone does this more than once though, they're going to very quickly realize that the card always goes right there. Now what we can do, so we're going to try to do something about that. I don't think I'm going to try to solve the problem with the looping one too many times, maybe. Render, yeah. While selected row, like this prompt I feel like should be at the bottom. You know? Doesn't that make sense to anyone? Like the selected row, the third time. You've done this 2 times. You're here, this is the 3rd time. Selected row is definitely not 1. It's undefined. So we're going to do this once. Reveal card rows, render card rows, and prompt for the index. Oh, okay. It's because we have to render it at least once. So we have to render once so that they can pick two, so that they can say now it's finally in the right place.
I'm not sure I understand what the problem is, though.
Well, the problem is if we put render as the first thing inside this loop.
Okay, so you're on the very first loop, or
Maybe
are you
they're.
on the last loop?
This is on the second. This is the so this is after it's gone twice.
Okay, so it's gone twice.
Yeah. We're gonna render first. Okay, maybe. Then we prompt. We always prompt after rendering, and then we redeal according to what they selected. I guess this way works better. So what I think I was thinking before is that if we redeal after they've selected, then we're going to ruin, and the only way to do it in this order where render is the first is to have redeal be the last. So I think I was thinking, well, we can't redeal it at the end because that'll ruin the trick. But in fact, it won't. Like if you redeal as many times as you want, that ace is going nowhere because that's row 2. You redeal it, it's still right in the same place. I'm pretty sure. So this actually should work fine. We have an extra unnecessary redeal because they prompted it's 2, and we're not even going to do anything with the redealt card, but it doesn't matter.
Because we had the initial deal, and then one after that, and then one after that.
We have at least 3.
You're saying that there was an extra.
We have at least 3, and they just prompted 2 after at least 3, which I think is the only thing you need for the trick. Okay. All right, so I think this will work just as well. Let's.
This is the initial.
Yeah. Do you want to pick one?
5
5 of diamonds. That is in row 1.
Okay, so this is
Number
number 2.
2. 5 of diamonds is in row 2. Number 3.
Now we're on number 3.
5 of diamonds is row 1 though, so it won't end yet.
Okay, so we gotta go to a fourth one.
Yep.
And there it is.
There it is. 5 of diamonds. 2, and we're done. 5 of diamonds. Boom. Okay. So what happens? What happens if we pick the very middle card? Let's just see. If we pick the 5 of hearts, we say it's in 2. It doesn't move. 2, 2, 2. Your card's 5 of hearts. This works. I think we got it solid. We got it. And I
Okay, because we have an initial deal, and then we have
Yep,
3
yeah.
redeals.
Well, and this last redeal is not used. We don't use the cards or show them or anything after this, but that's fine. It works this way better because the loop itself is simpler. Even though there's an extra unnecessary computation at the end, we don't really care. Yeah.
So my question is that first deal even, I mean, it's counted as far as the code, but is it counted as far as our initial shuffle and redeal? Because at that point when we do the initial deal, they haven't even selected the card yet.
What do you mean by deal? Do you mean shuffle or do you mean show?
This is shuffle,
Okay.
This is deal.
Okay.
So when you first have the cards out in the 3 rows,
Yeah.
and they pick.
Yeah. We have shuffled because deal card rows shuffles before giving them to you. It just gives you random cards.
Right, and I'm not right. So what I'm saying is, when the cards are initially laid down, that is really like the initialization of the project with 3 redeals on top of that. What I'm saying is that maybe our thought.
No, you have to, the initial before any of the loops, that doesn't count as one of the 3 because you have to, what a deal means is they've picked the pile it's in and you've shuffled. So the picking happens here the first time. Here again, and then here. And then the next time they pick 1, it would break out of this. So that's enough. That's 1, 2, 3. That's
Right, but we're getting 4.
We're not getting 4. I don't think so. Let's see.
There was the initial deal, and then
This is not. This doesn't count yet.
That's what I was saying.
Yeah. Yeah.
So this doesn't really count as a deal. This counts as more of the
This is just show. Yes,
This
just
is
a show.
initialization
Right.
of the whole process.
Right. Yeah. That's. I guess. Yeah. That's a separate thing. This is not.
Okay.
I think deal and redeal are bad names for this. I've realized.
And that's what I was speaking to. That maybe our thought process about how we were naming these steps is the issue versus
Yeah.
the actual function.
Well, this is. I mean, this is the bread and butter of what we do all the time. We just spend an hour at work trying to determine the names of different things like units of currency and stuff. I mean, I think we could
So
rename
naming conventions definitely make
a
difference.
huge
and
difference.
can
Yeah.
kind of make or break how quickly a team gets through something.
Yeah. Yeah.
Because it's like we're saying the same thing, we're saying it differently, but because of that one little word that we're not communicating
Yep.
on, it's like, oh, we were talking about the same thing.
Okay.
We had to pull the visual up to see that.
But let's make sure two, done. 3 times. Okay. It does the prompt 3 times, which is what we want. We need to rename it. What I'm going to do, though, we have about 10 minutes left. I think I'd like to try to make it so that when it shows the cards, and only when it shows the cards, it at least randomizes the row so that it's not so obvious that it's just the middle card in the middle row every time. It'll always be in row 2 when it is over, but most people won't pick it up after once or twice. So that's much more effective. We'll try to do that, and then I'll add the comments after today, and then after that in a separate commit. So I'll send links to these commits separately, but in a separate commit, I'll try to think of a better set of names. Or if anybody wants to try to improve the names, that could be extra. That could be the actual extra credit today, or double extra credit.
I'm just thinking that at the initialization of the game, maybe it should just be like a knit deal or.
Yeah, deal card rows and redeal.
Yeah,
That's too confusing. Yeah.
I mean, but we have to figure out a way for it to be less confusing.
What if we just call it initialized card rows?
There you go.
So I will go deal card rows, make it case sensitive so you don't capture that capital D there. And there's only one other place where it is. So we replace both of these names. Everything should work the same. The call and the definition now have new names. Thank you. That's a good name. Initial.
So if we want to let at the initialization of this, we let the player know the game has started.
Okay.
Pick a card, and then when it loops after that, say pick another card.
That's a very good idea, to have a user interface, which makes sense and doesn't require a human assistant. So yes, let's just console.log, pick a card and remember it. And then the next prompt is going to be which row is your card in.
Yes, I like that.
Okay.
I think that clarifies what's going on.
So it might get a little hidden here. Actually, we might want to render it under the rows the first time, but that would screw up our loop. So let's render it on the top. Pick a card and remember it. Okay. Okay. So we see pick a card and remember it. There it is. Which row is your card in? Okay. Jack, I'm doing the Jack of Hearts. 2, 1, 2. Got it. Cool. It's working. Thank you. Applause. Okay, let's make it a little less obvious, and then we're done for today.
So if it's less obvious to everybody else, though, then how are we going to know which one it is?
That's exactly the point of doing this. It's like if we were to shuffle the cards around in our rows and then display them, we're going to have them in the wrong order. It'll be somewhere else, and you never know. It'll go to the end, and then someone will pick it, and now they're in the wrong order. So when you redeal them, it'll ruin the trick, right? That's the problem we have. So this is like kind of where you really want to. This is a very this will come up. This core idea will come up in React and in that kind of user interface principles. What we want to do here is we don't want to modify the data we're maintaining. The data we're maintaining is the trick data. We keep track of what people choose. We keep track of all the cards in the correct order so that when we deal them, the thing we want happens. None of that's going to change. And see, we only have to change exactly one thing. We have to make a copy of the cards and shuffle them up before we show them. That's it. We just make a copy of all this data, shuffle the order of each row, and then we show them like that. We show them the copy that's shuffled. And that's the only change we're going to have to make. Now, yeah.
So the computer knows the copy, but you don't like print that to
You don't ever print the internal one. You print the shuffled copy, and the computer still remembers the original one. So when they pick the rows are still the same, and you still have the one that's not shuffled, and you continue with that one, and you shuffle it again. Yeah. So that should be very easy to do.
So if you don't mind, I would like to challenge myself to how much I can remember what each part does. So if you could push like an uncommented version,
Sure.
and then push the commented version.
I will make an index.js underscore uncommented.
Right.
I'll remove all the comments, and then I'll leave the index.js with the comments.
With the comments, so
Yeah.
that I can
Yes.
see, how much I'm able to retain as far as
Okay.
which part is doing which.
Cool. That sounds
And
like
then start
a great idea.
Okay.
All right, I will get both of those. First, let's try to figure out how we're going to shuffle up. Now this, because what we have just described, it's only when we're showing it. So the only thing we should have to touch of all of this is the render function here. We're handed card rows. We should not mess with them, but we should show a messed up version of each row. That's all. So we have a card row here. And look at this. We've already kind of made a copy of each of the cards by converting it into each one as a string. These are totally separate. Our card symbols array is totally different from card row. It has different data inside of it. We can do anything we want to that right now because all we're going to do is log it and then throw it away. So we can just, all we really have to do here is jumble up card symbols. Now, this is where I'm like, how do you jumble up an array of 7 things in JavaScript? And I don't know, and I didn't look it up beforehand. So we're going to go to the internet and start there. Say, shuffle array of objects JavaScript. That's what I want. Okay, how to randomize an array in JavaScript. Pretty cool. Easier than sorting it out yourself. Now, if you wanted to get the knowledge and the, but we only have 10 minutes, so we got to go right to the internet, quickly copy this in. Okay, how do I randomize shuffle it? The unbiased shuffle algorithm is the Fisher-Yates shuffle. This is probably what the card deck uses internally. But here is a function called shuffle. We can copy that. We can go back to our code. We can paste it. We could put all this in line. It doesn't have to be a function. Shuffle function we copied from Stack Overflow. And if you're being a good citizen of a license, if this is somehow licensed, you can include, be a very classy thing to do in a code base. You can include the link to it, the comment. So you put you click share here, you grab that, and your coworkers will be like, "This is one classy programmer," because you're attributing it. You're like, I didn't plagiarize this. I'm attributing it. Okay. So let's see if this works. If we just run it, card symbols equals shuffle this. It's a little too wide. It should be the right thing. Let's see. Okay. Anyone want to pick the card? This is very. Okay. Not a club. 9 of clubs. 1, 2, 3. It's in 2. That's a good sign. 2. Whoops. Now it's in 2. Boom. 9 of clubs. So we've successfully fooled the humans. They didn't notice the computer. It didn't end up in the middle, but it is keeping track. Let's make sure this wasn't a fluke. Someone pick. 2 of diamonds. Third row. Now it's in the second row. Now it's in the first row. Well, it's in the middle this time, but that's an accident.
Okay, try it one more time.
All right. Okay, so I'm going to pick the 6 of clubs. 3, 2, where is it? 1, 2, it's 6 of clubs. It's all the way to the end. Yeah, very cool. All right, so yeah, let me check in this last. I will check in this last thing. Don't look at it yet. If you want, I'm going to sort out the comments, make the uncommented version, add the comments to this one right after class. Yes. Make a program. So the homework is there's 2 problems to solve. Make a file if you want for each one, or a function if you want for each one in the same file, and just write the function that does what the problem is asking you to do. Name it the problem if you want. Name it, FizzBuzz or whatever, and then put that file up on. Push that file up in your sandbox. Push it up to GitHub. It's in the slides. There's 2. They're at the end of the chapters in Eloquent JavaScript, and I've just named them. They're at the very end. There's one called FizzBuzz in chapter 2, and there's one called bean counting or bean something on chapter 3. Yeah. Okay. So let me commit this, and we're good. Is there anything else anyone wants to go over? We have only a couple minutes left. We could just break early, or any questions about this? That is pretty sweet. I agree. Three. Well, so that's JavaScript fundamentals. Pretty much for the rest of the course, you're going to be doing things that touch JavaScript. But there's going to be, purpose. It'll be use JavaScript now to make a server, and then use JavaScript to do this and other stuff. But yeah, I think there's 3 more weeks of just fundamentals. Okay. Yeah. All right. Well, I think I'm going to end the internet stream. Yeah. Yeah, sure. Push to GitHub. Oops. All right. That's the end of the class. So long, internet.